video, I'm going to discuss on the topic of introduction to computer and generations of computer, tokens in C, structure of C programming. Let's start with the introduction to computer. Introduction to computers. Computers have become an essential part of daily life and various industries. They are electronic devices that manipulate data and perform calculations at high speed. Understanding the basics of computers is crucial in today's digital world. What is a computer? A computer is an electronic device that processes data according to a set of instructions. It can perform operations such as input, processing, output, and storage of the data. Computers can range from small handheld devices to large supercomputers. Components of computer. The main components of a computer include hardware and software devices. Hardware refers to the physical parts of the computer such as CPU, RAM, and hard drive. Software consists of programs and applications that run on the hardware systems. Types of computers. There are several types of computers, including desktops, laptops, tablets, and smartphones. Each type is designed for specific uses, from general purpose tasks to specialized applications. Supercomputers are used for complex calculations and data analysis in scientific research and in present time. Input and output devices. Input devices allow users to enter data into a computer, such as keyboards and a mouse. Output devices display or present the results of the computer processing, like monitors and printers. Understanding these devices is essential for effective computer usage. Operating systems, namely short form OS, is a software that manages computer hardware and software resources. Popular operating systems include Windows, Mac OS, and Linux. The OS provides a user interface that allows users to interact with the computer. Applications of computers. Computers are used in various fields including education, healthcare, and business. They aid in tasks such as data analysis, graphic design, communication. The versatility of computers has transformed how we work and live. Internet and networking. The Internet is a global network that connects millions of computers worldwide. Networking allows computers to share resources and communicate with one another. Understanding basic networking concepts is crucial for using computers effectively. Security and privacy. Cybersecurity is vital for protecting computers from threats such as viruses and hacking. Users must adopt safe practices to safeguard personal information online. Regular software updates and strong passwords are key components of digital security. The future of computing. The field of computing is rapidly evolving with advancements in artificial intelligence and machine learning, that is AIML. Quantum computing promises to revolutionize processing capabilities beyond current limits. Staying informed about technological trends is essential for future preparedness. Now, moving on to the next slide, let's understand generation of computers. Introduction to computer generations. The concept of computer generations refers to the different stages of technological development in computer systems. Each generation is characterized by significant technological advancements and innovations. Understanding these generations helps us appreciate the evolution of computing technology over time. First generation. From 1940 to 1956, the first generation of computers used vacuum tubes for circuitry and magnetic drums for memory. These machines were large, expensive, and consumed a lot of electricity. Programming was done in machine language, making it difficult and time consuming for programmers. Second generation from 1956 to 1963. The second generations replaced vacuum tubes with transistors, leading to smaller, faster, and more efficient machines. These generations introduced assembly level language, which made programming more accessible. Computers became more reliable and were used in various fields, including business and education. Let's move on to third generation. Third generation is from 1964 to 1971. The third generation saw the development of IC chips, that is integrated circuits, which combined multiple transistors into a single chip. This innovation drastically reduced the size and cost of computers while increasing their power. Operating systems evolved, allowing multiple applications to run simultaneously on a single computer. Fourth generation, 1971 to the present time. The fourth generation is characterized by the development of microprocessors, which are the brains of modern computers. Computers became increasingly user friendly with the advent of graphical user interfaces. This generation has led to the proliferation of personal computers and the internet. Fifth generation, present and beyond this. The fifth generation focuses on artificial intelligence and machine learning technologies. Quantum computing is also being researched, promising exponential increases in processing power. This generation aims to create computers that can think, learn, and interact with humans more naturally. Let's move on to the next topic, structure of C programming. Structure of C programming. Let's understand. Introduction to C language. C is a high level programming language that was developed in the early 1970s. It is widely used for system programming, embedded systems, and application development. C provides low level access to memory and system resources, making it powerful and efficient. Basic structure of a C program. A C program typically starts with a preprocessor directive such as hash include. The main function serves as the entry point of the program. Code execution begins from the main function and other functions can be defined and called within it. Data types in C. C supports several fundamental data types including int, float, char, and double. Each data type has a specific size and range which can vary based on the system architecture. The specific size of int is 2 bytes, float is 4 bytes, char is 1 byte, and double is 8 bytes. Understanding data types is crucial for effective memory management and program performance. Control structures in C. C provides various control structures such as if, else, switch, and loops like for, while, and do while. These structures allow for decision making and repetitive execution of code blocks. Proper use of control structures is essential for creating logical and efficient programs. Functions and modular programming. Functions in C help in organizing code into reusable blocks, improving readability and maintenance. A function is defined with a return type, name, and parameters and can return a value. Modular programming promotes code reuse and separation of concerns, making it easier to manage larger projects. Next, let's understand tokens in C programming. Tokens in C programming. Introduction to tokens in C. Tokens are the smallest individual units in C program. They form the building blocks of the syntax and semantics of the language. Understanding tokens is essential for writing and interpreting C code effectively. Types of tokens. There are six primary types of tokens in C, such as keywords, identifiers, constants, string literals, operators, and punctuators. Each type serves a distinct purpose, contributing to the overall structure of the program. Knowing the difference between these token types helps in writing syntactically correct code. Keywords. Keywords are reserved words in C that have special meaning to the computer. Examples of keywords include int, return, and if, which dictate the flow and structure of the program. Using keywords incorrectly can lead to compilation errors as they cannot be redefined or used as identifiers. Identifiers and constants. Identifiers are names given to various programming elements like variables, and functions. They must begin with a letter or underscore and can contain letters, digits, and underscores. Constants represent fixed values that do not change during program execution, such as numerical literals or string literals. Operators and punctuators. Operators are symbols that perform operations on variables and values such as arithmetic or logical operations. Punctuators are characters used to separate tokens like semicolons, commas, which help to define the structure of statements. Understanding how to properly use operators and punctuators is crucial for effective programming in C. Thank you everyone for watching video till now.